We are on problem 18. At time, so they write this, gives an equation. H of t is equal to c minus d minus 4t, all of that squared. At time equals 0, a ball was thrown up from an initial height of 6 feet. Until the ball hit the ground, its height in feet after t seconds was given by the function h above, in which c and d are positive constants. So they're telling us at time 0, we're already at height 6, right? So h of 0, time 0, the height is already 6. If the ball reaches its maximum height of 106 feet at time 2.5, so h of 2.5 is equal to 106. What is the height in feet of the ball at time t equals 1? So we want to figure out h of 1. That's what they want to know. So in order to figure out h of 1, we essentially have to figure out what c and d are going to be, right? So how can we do that? Well, we know what h of 0 is, so let's substitute. So h of 0 gives us this. Let's put t equals 0 here. You get c minus d minus 4 times 0, 4 times 0 squared. And that is equal to 6. And then if we simplify this, this is of course 0, right? So you get c minus d squared is equal to 6. Now the second equation, h of 2.5 is equal to 106. So that means that c minus d minus, what's 4 times 2.5? 4 times 2.5 is 10, right? I put 2.5 in for t. So d minus, I just did that to save some space, d minus 10 squared, and that is equal to 106. And now if we want to multiply this out, just to see where this takes us, because actually I don't know where it will, you get c minus, and then I'll put it in brackets because this is going to be a long expression. Multiplying this out, you get d squared minus 20d plus 100. And all of that equals 106. And then distribute the negative sign, so you get c squared. Sorry, this isn't a squared. I don't know where I got the squared from. See what happens when you take the SAT. C minus d squared plus 20d minus 100. I just distributed the negative sign, is equal to 106. And then let's see, we could add 100 to both sides. You get c minus d squared plus 20d is equal to 206. I just added 100 to both sides. So we're left with two equations. We're left with this. C minus d squared is equal to 6. And then we're left with this. C minus d squared plus 20d is equal to 206. And something should be jumping out at you. There's a c minus d squared in both terms. C minus d squared is 4. Oh, no, sorry, c minus d squared is 6, the previous equation tells us. So we can substitute 6 right here. So if you put 6 there, you get 6 plus 20d is equal to 206. Subtract 6 from both sides. 20d is equal to 200. D is equal to 10. Now, if we substitute d equals 10 back into c minus d squared, what do we have? D is equal to 10, right? So c minus 100 is equal to 6, or c is equal to 106. And if you have an intuition for how parabolas look, you probably could have not guessed, you probably would have known that. You would have known that c is actually going to be the peak point of this parabola, and they tell us that the peak point is at point 106. And then you could have solved for d from there. But if you didn't have that intuition, you could have just chugged through the algebra like we just did. So we know c, we know d, so we know the function is now h of t is equal to 106 minus 10 minus 4t, all of that squared. And so we want to know what happens when t equals 1. So h of 1 is equal to 106 minus 10 minus 4 times 1, so 10 minus 4 squared. So that equals 106 minus 6 squared equals 106 minus 36, which is equal to 70. And we are done. H of 1 is equal to 70, which took us a little time, but it was worth it. I'll see you in the next